microcosm.
Ladies and gentlemen, cosmic adventurers, dreamers who look up at the stars and wonder what's out there. Welcome back to Top Cos, your gateway to the infinite wonders of the universe. Today, we're igniting the thrusters on an epic voyage through history, counting down the top 10 space missions that didn't just explore the cosmos, they revolutionized how we see it, shattered old assumptions, and opened our eyes to realities we never imagined. These aren't mere trips into the void. They're bold leaps of human ingenuity, powered by science, that have rewritten the textbooks and expanded our collective mind. From the first beeps of a tiny satellite to telescopes peering back to the dawn of time, these missions have shown us that the universe is bigger, stranger, and more magnificent than we ever thought. So strap in, folks. We're blasting off from number 10 to the pinnacle at number 1. And by the end, you'll feel the awe of discovery pulsing through your veins. Kicking us off at number 10, Sputnik 1, the little sphere that launched the space age in 1957 and changed everything overnight. Imagine the shockwaves when the Soviet Union hurled this 184-pound beach ball-sized satellite into orbit, beeping its simple signal around the world. It wasn't just the first artificial object to circle Earth, it proved we could escape our planet's grasp, sparking a global race that poured billions into science and technology. Before Sputnik, space was a realm of dreams and sci-fi novels. After, it became a frontier we could conquer. Orbiting every 96 minutes, it revealed the harsh environment of space, from radiation to microgravity, and forced us to rethink our place in the cosmos. We're not just earthbound, we're spacefaring beings. This mission didn't carry fancy instruments, but its mere existence ignited imaginations, leading to satellites that now monitor weather, GPS, and even climate change. Sputnik wasn't about conquest, it was a wake-up call, reminding humanity that the stars are within reach if we dare to launch. Zooming to number 9, Explorer 1, America's fiery response in 1958 that uncovered the invisible shields protecting our planet. Hot on Sputnik's heels, this pencil-shaped probe, launched atop a Jupiter C rocket, became the first U.S. satellite, and stumbled upon one of the cosmos' great secrets, the Van Allen radiation belts. Those looping bands of charged particles trapped by Earth's magnetic field were a total surprise. Scientists thought space was empty, but explorers' Geiger counter went wild, revealing a hazardous zone of high-energy protons and electrons that could fry electronics and endanger astronauts. This discovery didn't just map our planet's protective bubble, it transformed our understanding of solar winds, how solar winds interact with magnetic fields across the solar system, and even hinted at similar phenomena around other worlds like Jupiter. Weighing just 30 pounds, Explorer 1 operated for months, sending data that laid the groundwork for safe space travel. It's a testament to curiosity-driven science. Sometimes the biggest revelations come from the smallest packages, shielding us from the universe's fury while inviting us deeper in. At number 8, we have Mariner 4, the plucky probe that in 1965 gave us our first close-up glimpse of Mars and dashed dreams of Martian canals and little green men. Flying by the red planet after a 7-month journey, this NASA trailblazer snapped 22 grainy photos that revealed a barren, crater-pocked world, not the lush, water-filled paradise imagined by astronomers like Percival Lowell. Those images, transmitted across 134 million miles, showed ancient impact scars and a thin atmosphere, forcing us to rewrite our ideas about planetary habitability and the solar system's violent past. Mariner 4 proved Mars was more moon-like than Earth-like, sparking questions about where life might hide, if at all, and paving the way for future rovers to dig deeper. It also tested interplanetary navigation, surviving cosmic rays and equipment failures, teaching us how to command spacecraft from afar. This mission wasn't glamorous, but it grounded our fantasies in cold, hard data, transforming Mars from a myth to a scientific puzzle we're still solving today. Number 7 takes us to the moon with Apollo 11 in 1969, the audacious landing that planted humanity's flag on another world and brought back rocks that unlocked lunar secrets. Neil Armstrong's one small step wasn't just a TV spectacle, it was a scientific bonanza. The astronauts hauled back 48 pounds of moon rocks, revealing the moon formed from a colossal Earth impact billions of years ago, sharing our planet's isotopic fingerprint. Seismic experiments left behind detected moonquakes, hinting at a molten core, while laser reflectors still let us measure the moon's slow drift away from Earth. This mission shattered the notion of the moon as a static, dead rock. It showed it's a dynamic body, battered by asteroids with a history intertwined with ours. Amid Cold War tensions, Apollo 11 united the world in awe, proving international collaboration in space could transcend politics. It changed our cosmic perspective. If we can walk on the moon, what other worlds await our bootprints? The legacy? A blueprint for exploration that inspires Artemis missions today. Halfway up at number 6, the Voyager probes, launched in 1977, those intrepid twins that toured the outer solar system and became our first interstellar ambassadors. Voyager 2 alone flew by Jupiter, Saturn, Uranus, and Neptune, revealing raging storms on Jupiter, intricate rings around Saturn, geysers on Triton, and 10 new moons at Uranus. These discoveries painted the gas giants as active, chaotic worlds, with magnetic fields twisting like cosmic pretzels and atmospheres brewing exotic chemistries. Voyager 1's pale blue dot photo from 4 billion miles away humbled us, showing Earth as a tiny speck in the vastness, urging environmental stewardship. Now beyond the heliosphere, they're sampling interstellar space, detecting cosmic rays and plasma waves that redefine the sun's influence. Carrying golden records with Earth's sounds and images, they're humanity's message in a bottle to the stars. Voyagers didn't just map planets, they expanded our view of the solar system's diversity, proving it's a family of worlds full of surprises. Number 5. The Hubble Space Telescope. Orbiting since 1990, the eye in the sky that pierced the veil of the universe and revealed its ancient history. After a blurry start fixed by astronauts, Hubble's deep field images, staring at empty sky, uncovered thousands of galaxies billions of light years away, pushing the universe's age to 13.8 billion years and confirming the Big Bang's accelerating expansion via dark energy. It spotted protoplanetary disks, supermassive black holes gobbling stars, and even helped discover Pluto's moons. Hubble's ultraviolet and infrared views exposed star births in nebula and the afterglow of supernovae, refining our models of cosmic evolution. This isn't just a telescope, it's a time machine, showing us the universe as it was eons ago, challenging theories on dark matter and galaxy formation. Despite 30-plus years of service, its data fused breakthroughs, like measuring the Hubble constant. Hubble changed astronomy from ground-based guesses to space-based certainties, making the cosmos feel intimate and infinite at once. Cranking the excitement for number 4, Cassini-Huygens, the 1997 mission that dove into Saturn's realm and unveiled a watery wonderland on its moons. Orbiting for 13 years, Cassini mapped Saturn's hexagon storm, dissected its rings as dynamic ice particle highways, and discovered new moons. But the jaw-dropper? Huygens probe landing on Titan, revealing methane lakes and a hazy atmosphere mimicking early Earth, hinting at prebiotic chemistry. Then, Enceladus, geysers spewing water plumes with organics and hydrothermal vents, suggesting subsurface oceans that could harbor life. Cassini redefined gas giants as systems teeming with potential habitability, challenging our Earth-centric view of life. Its grand finale plunge into Saturn's atmosphere in 2017 protected those moons from contamination. This mission wasn't exploration, it was revelation, showing the outer solar system as a hotbed of geological activity and astrobiological promise. Number 3 takes us to the Kepler Space Telescope, launched in 2009. The planet hunter that flooded us with exoplanets and proved we're not alone in the galactic neighborhood. Staring at 150,000 stars, Kepler detected over 2,600 worlds by spotting tiny dips in starlight as planets transited, revealing hot Jupiters, super-Earths, and even systems with multiple planets in habitable zones. It shattered the idea of our solar system as unique, showing diverse architectures, some with planets orbiting binary stars, others packed tighter than our own. Kepler's data estimated billions of Earth-like planets in the Milky Way, fueling SETI searches and redefining astrobiology. Despite wheel failures, it pivoted to K2, finding more gems. This mission transformed exoplanets from rarities to commonplace, urging us to ask if planets are everywhere, is life? Kepler's legacy lives in TESS and beyond, making the stars feel crowded with possibilities. Runner-up at number 2, New Horizons, the 2015 speed demon that unveiled Pluto as a vibrant, geologically active dwarf planet far from the frozen rock we assumed. Racing at 36,000 miles per hour, it snapped high-resolution photos of Pluto's heart-shaped plain, nitrogen glaciers, and hazy atmosphere, plus Charon's craters and chaotic moons. Discoveries like cryovolcanoes and possible subsurface oceans challenge models of Kuiper Belt objects, showing their dynamic relics from the solar system's birth. New Horizons then flew by Arrokoth in 2019, a pristine